Hello, I'm Vicky Sandoval.
Hello, this is Austin Reed.
Hi, this is Hakim.
I'm Anas. The Advanced Energy Vehicle Design Project requires a team of engineers to design and develop an AEV capable of performing a set of operations efficiently. The team's major goal for the AEV project will be creating an AEV that will successfully travel a set distance, stop at a gate for a few seconds, and continue on to pick up the cargo with R2-D2. The AEV would then travel back, stopping again at the gate and continuing the journey back to the starting point. The group's goals for this project would be to design an AEV that would not only be functional and efficient, but also have a design that would be slick and futuristic. For the team's AEV design development, each team member made an individual design of their own, which was then evaluated through the concept screening and scoring matrix, where a weightage was assigned to a certain criteria, and the individual designs were rated based on that.
The first design made by Vicky obtained a weighted score of 2.15 as it would use a lot of energy due to its weight in addition to its rather high price despite having a low minimal blockage. The next design by Anas only obtained a weighted score of 2.1. Despite being well balanced, it was very hard to maintain as the design was quite complicated. Hakim's design scored a weighted score of 2.65 as it consumes lots of energy and also hard to maintain. Austin's design scored the highest, which was 3.75. It has the best durability and it used the least component, which costed less. However, it was not good for minimal blockage.
For the final design, the team stuck with a vertical design with propellers placed on either side for a pusher and puller configuration to move the vehicle as effectively as possible, and used 30-30 propellers because they were optimal. As seen here, the overall design of the AEV was minimalistic and extremely lightweight, giving the team a great idea for the AEV's code. Due to its design, the AEV was able to glide along the track for long distances without any energy being provided to it. So the AEV was given a small amount of power for a certain distance before being cut off and gliding either to the gate, the cargo bay, or the finish line. Let's see how we did. For the first segment of the track, the power was cut off from the AEV just before the curve, and there it goes, slowing down perfectly for the first sensor. A similar method was used to get the AEV to the cargo bay. Due to the additional weight of the cargo, the AEV was supplied with more energy to move at a consistent pace, and the power was cut off just after the curve because it wasn't able to glide as far. This technique was used to get the cargo back to the starting point as outlined by the mission concept review. Overall, we completed our final run using only 218 joules of energy and used on average 215 joules.
Throughout the AEV design project, the team learned that energy efficiency did not only depend solely on the design of the AEV itself. Rather, the programming that operated the AEV also played a major role in determining its efficiency in operation. Hence, we learned that what we could have done differently was to focus on the structure of the Arvidian code for the AEV, which would greatly help in reducing the energy usage of the AEV. Another meaningful lesson that was learned from the design project was through thick and thin, teamwork was the main key in ensuring the team's success for this project. We experienced many obstacles along the way, but due to the patience and the resilience of all teammates, everything went well in the end. Among the obstacles that the team faced was first, one of the team's motors were wired improperly, causing it to rotate in the opposite direction. It took a few labs before we realized it, having it then utilized in our final design. The second obstacle was having an unpredictable battery, where the team's AEV was inconsistent in terms of performance during various runs, yet the battery encode was the same, which relates to the next obstacle, inconsistent code and trouble pairing it with the AEV. It took many runs and trials, constantly tweaking the code and changing the batteries, until finally the team succeeded to operate the AEV to perform a successful full run on the track, which kept consistent until the final testing. The last obstacle that the team faced was the bumpy track in room 308, where the team's AEV became stuck and did not perform optimistically due to the track in the room. The team decided to perform the final testing in room 224 to ensure the team's AEV performance during its run. All in all, the team had a wonderful experience participating in the AEV design project and see it as a stepping stone to become future successful engineers.